we were given the matrix M, which is equal to 2, 1, 4, 3. We were required to find its inverse, which we found to be a half of 3, negative 1, negative 4, 2, which we converted to this form by dividing each term by 2. We will show that M times M inverse is equal to I. The product of M and its inverse will give us I, which is the identity matrix for the multiplication of 2 by 2 matrices. I is not limited to 2 by 2 matrices, but it is 2 by 2 on this occasion. Also, the matrix I is 1, 0, 0, 1. Finding M times M inverse, we will not use the version of M inverse that contains the fraction. We will take the fraction outside, making the process less complicated. And that is why we are using this one, the one with the fraction outside, which will make the process less complicated because we will be manipulating only whole numbers. Now we have M inverse to be multiplied by M, which is this one, which is this one. And when we multiply those, as a matter of fact, when we multiply M times M inverse, although matrix multiplication is not commutative, for this special case, it does not matter if we multiply in the order M times M inverse or M inverse times M. Begin by carrying the fraction to the proposed product. This is the proposed product that has no element at the moment, but we will be multiplying by a half in the end because we are not using it in the beginning or at any other place in the process. We will wait until the process is finished, then we will apply the half. Let us make provision for that very early. We are required to multiply the matrices, and we will do so by saying row times column. Row times column, as we have it right there. Finding the product of the matrices, rows of the first are used to multiply columns of the second. Each element will be a sum of products. We will take a look at the synthesis on a subsequent audiovisual. And I know what you will be saying after you finish watching this audiovisual. If the process can be explained simpler than we are doing it here, well, you be the judge of that. Rows of the first times column of the second, and we will have a sum of products. There we go. We are beginning with the first sum of products. The first element of the first row is used to multiply the first element of the first column. So it's always first times first, second times second. So we'll have 3 2's. We will not simplify yet. Then we will take the next product, negative 1, 4, right there. Maintaining the first row, we will move to the second column. 3 times 1, negative 1 times 3. Because it is what? First times first, second times second. When we are through exhausting the 2 columns with the first row, we will move to the second row. which will be used to multiply both columns. So we have first times first, that is negative 4 times 2, and then we will have 2 times 4. Next, negative 4 times 1 with 2 times 3. All the time, first times first, second times second. We are finished with the multiplication process. Then we will just simplify, and that's the end of it. 6 negative times positive, negative 4. 6 minus 4. 3, of course, minus 3. Negative 8 plus 8. Negative 4 plus 6. 6 minus 4. 3 minus 3. Negative 8 plus 8. Negative 4 plus 6. Then, no difficulty, 6 minus 4 equals to 3 minus 3, that's 0. Negative 8 plus 8, that is 0. And negative 4 plus 6, that is 2. What do we do next? We are multiplying by a half here. We'll take half of these. And if we take half of these, then we know half of 2 is 1 and half of 0 is 0. So there we will have our result. Can be easily seen without that intermediate step. So I is equal to 1, 0, 0, 1. And we have shown that when we multiply a matrix by its inverse, the result is the identity matrix, which we know to be 1, 0, 0, 1. I is the multiplicative identity matrix for 2 by 2 matrices. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.